Good afternoon, my YouTube viewers. We're going to be covering in this video the last video in this section and the last video in this course. So if you've watched every single video in this playlist, which it is a complete course, then congratulations. When you finish this video, you will have finished the course. And what we're going to do in this video is we're going to perform a difference in mean test, but we're going to perform a two-sample t-test on the ages of men and women MBA students. So the null hypothesis is men's ages equals women's ages, and the alternate hypothesis is men's ages do not equal women's ages. So I'm giving you a list of men's ages, which are 23, 24, 25, 36, 27, 28, 29, 30, 31, 32, 33, 34, 35. And then the women's ages are 25, 26, 26, 28, 29, 30, 29, 28, 27, 26, 25, 26, 27. And what we're going to do is we're going to write a program in Python to solve this problem. But before we write the program in Python, we're going to have to import libraries, because we need to import these libraries so that the program will be executed. So the first library we're going to import is NumPy as NP. NumPy is a numeric library that makes numerical calculations. It creates NumPy arrays, and it also creates distributions. And then we're going to import scipy stats as stats. So scipy is Python's scientific library. Stats is a statistical module within scipy. And then we're going to import matplotlib.pyplot as plt, which is a visualization library. So we're going to define the ages of men and women, which I've already told you about just a few seconds ago or a minute ago. And then we're going to calculate the means. So mean equals np.mean men ages, and women mean equals np.mean women's ages. We're going to calculate the standard deviations. So means equals np.std brackets men ages, comma, DDOF equals 1, and DDOF is degree of frequency. Degree of freedom. And women's STD equals np.std brackets women's ages, comma, DDOF equals 1. So we're going to calculate the sample sizes. Men size equals len men age, and women size equals len women age. And I believe that there's 13 elements in both the men and the women. And now we calculate the t-score. So t-score equals brackets men mean minus women mean brackets divided by the square root of men standard deviation squared divided by men size plus women's standard deviation squared divided by women's size. And that gives you a value of 2.1473. So we calculate the degrees of freedom, and we're going to use the Welch-Satterthwaite equation to do that. And using the Welch-Satterthwaite equation, you have a degree of freedom of 15.39. But a simple way to calculate the degree of freedom is n1 plus n2 minus 2. And so if you did it that way, you would have a 24 as your degree of freedom. So you can see that the degrees of freedom, there's a big variance of differences between the degrees of freedom between the Welch-Satterthwaite equation and the simple equation that I've just noted above. But we're going to be using the Welch-Satterthwaite equation. Okay, so we're going to calculate the p-value for a two-tailed test. P-value equals 2 times brackets 1 minus stats.t.cdf brackets ABS brackets t-score, comma, df. So T means it's a T distribution, CDF is cumulative distribution function, ABS is absolute value, and DF is degree of freedom. So we're going to output the results of the men's mean age, women's mean age, men's standard deviation, women's standard deviation, and the t-score and the p-value. So what we're going to do now is we're going to determine our alpha as being 0.05, and we're going to analyze the p-value against the alpha. So if the p-value is less than alpha, which is 0.05, then you're going to reject the null hypothesis. There is a significant difference between the ages of the male and female MBA students. If the p-value is greater than alpha of 0.05, you're going to fail to reject the null hypothesis. There is no significant difference between the ages of male and female MBA students. So we're going to plot our data onto a graph. So x equals np dot line space brackets -4, 4, 1000, and y equals stats.t.pdf brackets x, df. So T is your T distribution, PDF is probability density function, and DF is your degree of freedom. So we're going to plot the T distribution. So PLT.plot brackets x, y, label equals T distribution, color equals blue. Then we're going to shade the critical region. Critical value equals stats.t.ppf brackets 1 minus alpha divided by 2, df. And so T is your T distribution, ppf is percentage point function, alpha is 0.05, and then df is your degree of freedom. PLT.fill between brackets x, 0, y, where equals x is less than or equal to negative critical value, or x is greater than or equal to critical value, color equals red, alpha equals 0.5, label equals critical region. Now we mark the t-score on the plot. We plot the AXV line, brackets t-score, color equals green, line style equals dashed, line width equals 2, label equals t-score. And now we add titles and labels to the graph. So the title is Two-Tailed T-Test Comparing Ages of Male and Female MBA Students. The X label is t-score, the Y label is probability density, and then you get a legend, and then we're going to show it. And so I'm going to show our work. So our degrees of freedom is 15.39. The men's mean age is 29.77. The women's mean age is 27.08. The man's standard deviation is 4.23. The women's standard deviation is 1.61. Your t-score is 2.1473. Your p-value is 0.0481. So your p-value is just below the 0.05. And since the p-value is just below the 0.05, you have to reject the null hypothesis because there is a significant difference between the ages of male and female MBA students. And so now what we will do is we will show the visualization that we created, which is a two-tailed test comparing ages of male and female MBA students. The blue line is your T distribution, your red is your critical region, and green is your t-score. And you can see that the t-score just barely made it into the critical region because the t-score is 2.15, but your p-value is 0.481. And since your TP value is 0.481, you had to reject the null hypothesis. But it's really close. It was touch and go. And so that concludes this video. And that concludes this course. If you've watched all the videos in this section and all the videos in this course, congratulations, and I hope you learned something.